go with Unit 6, momentum and impulse. And so here we've got a cart that undergoes a collision, and we're looking for some different things. So this is from 2001. Part A is asking you for the average acceleration, and you're using graphs here. So I took the points at time equals 0.33 and time equals 0.37. And since it's asking for average acceleration, I can just use the kinematics equation, delta V over delta T. You can see I plugged in my values. You did have to have the negative sign for your acceleration to get full credit. For part B, you have to determine the magnitude of the change in momentum in the cart's change in momentum during the collision. You had to have some indication that impulse is equal to the change in momentum or impulse momentum theorem. So you could have done it more than one method. I used area under the curve because I find it to be the fastest when you're given a graph like this. So I just literally split up my areas, the triangles, the rectangles, the two triangles, added them all together. You get 0.6 kilograms times meters per second. And then determining the mass of the cart, I use that the change in momentum is equal to mass times the change in velocity. I have my change in momentum from part B, which I plugged in. My change in velocity, I went from 0.22 to negative 0.18, and I find my mass to be 1.5 kilograms. Then they ask you for the energy lost in the collision. So I'm just taking the change in kinetic energy. Because it's on a flat track, there's no change in potential energy, so I just take the difference in my energy values for kinetic energy, and I find my energy change. So this one's a nice, straightforward one that you can do.